We're witnessing a rapid evolution in artificial intelligence, moving far beyond simply predicting words to achieving complex goals. This image breaks down that journey into three key stages: what large language models gave us, what retrieval augmented generation or RAG added, and where agentic AI is taking us. First, let's look at what LLM gave us. Initially, large language models like ChatGPT revolutionized how we interact with AI. At their core, LLMs are incredibly powerful prediction machines trained on massive static datasets of text and code. You give them a prompt, and their fundamental task is to predict the next most probable word in a sequence. This capability enabled breakthroughs in various applications: chatbots that could hold surprisingly coherent conversations, tools for code completion that boosted developer productivity, and text summarizers that could distill vast amounts of information. The paradigm here was simple. From a user input, the LLM generated the next word. It was a remarkable leap, but it was primarily about predicting words. Next, we move to what RAG gave us. While LLMs are powerful, their knowledge is limited to their training data and can become outdated. This is where retrieval augmented generation, or RAG, stepped in. RAG combines the generative power of an LLM with the ability to retrieve information from an external, up to date knowledge base. When a user sends a query, a retriever first searches a vast knowledge base. This could be internal company documents, recent news, or specific factual databases. The relevant information is then fed or augmented into the LLM's context. This allows the LLM to generate answers that are not only fluent, but also more contextual, factual, and personalized. RAG transformed reactive LLM into context aware AI, effectively moving us from merely predicting words to retrieving and generating accurate facts. However, it still largely remained reactive, requiring a prompt for every interaction. Now we're entering the era of what agentic AI gives us. This is the next frontier where AI systems evolve into autonomous agents. Imagine an agent as an AI entity capable of mimicking human like problem solving. Given a task or goal, an agentic AI can plan its steps, reason through challenges, act on its plans, and most crucially, learn from its outcomes. These agents are distinguished by having memory, allowing them to recall past interactions and knowledge, robust reasoning capabilities, and a degree of autonomy to pursue their goals without constant human intervention. A key development enabling this is multi agent collaboration, where different agents can work together, communicating through protocols like MCP and A2A. This allows for complex tasks to be broken down and solved by specialized AI units. Furthermore, agentic AI incorporates self improving through feedback loops, meaning they can analyze their own performance, identify errors, and refine their strategies over time, much like a human learning from experience. The applications are transformative, from workflow automation, where agents can manage and execute business processes end to end, to AI research agents that can explore and synthesize new scientific knowledge, all ultimately driving towards the goal achieved. This represents a fundamental shift from predicting words to retrieving facts to now achieving complex goals.